Let's go about deploying a 3-tier application on Azure using the DuploCloud bot. In this demo, you will see how using a very few inputs from high-level application specifications, the bot implicitly generates the infrastructure nuances. We will quantify the benefit by looking at the number of lines of low-level infrastructure as code that the user would have had to write otherwise. The deployment architecture involves a virtual network in the US East region. The application is split into multiple subnets within this virtual network, each with their own security groups. The infrastructure requires a log analytics workspace and a storage account. The virtual machine should be encrypted using Azure Disk Encryption, whose key is stored in Azure Key Vault. The web application needs to be exposed to the internet by an application gateway. Further, we want some best practices where each of these resources should be tagged with a business-specific context for accounting and management purposes. Let's get started. We log in to the DuploCloud portal, and we can start by creating what is known as an infrastructure. An infrastructure is a DuploCloud abstraction on top of Azure that represents a virtual network in a specific region. Among other things in the infrastructure, we have the subnets, which we're going to go ahead and input the specifications for now. Below this, you can see that we will also specify the log analytics workspace and security group rules. Key Vault is also included here. In the deployment architecture, there are multiple subnets. We're going to go ahead and creating one of these specific subnets by specifying the name and the prefix. Implicitly, the bot goes and creates a network security group for each subnet. If the subnet needs to be isolated from the rest of the virtual network for increased security, the user can specify that with a simple flag, and the bot will interpret it and convert it into the appropriate block rules for the network security group. Some of the subnets have to be a special kind. For example, after we finish this one, we're going to go ahead and create one for Bastion. By selecting the type of subnet, the bot will automatically do the necessary configuration for that type. For example, here for Azure Bastion subnet, it will create the appropriate security group rules and launch the Azure Bastion. Let's go behind the scenes into the Azure portal and see all of the various resources and low-level details that the bot has provisioned. We will see the virtual network, log analytics, Azure Bastion, and network security groups. We can see the various subnets within the virtual network. The network security groups will have various rules based on the subnet type. Now let's see what it would take for someone to automate this by writing code. Exporting the template, we see that 74 resources have been provisioned by the system. This involves over 2,000 lines of code, including the parameter file. We achieve this by inputting less than 15 fields into DuploCloud. Now that we have the infrastructure ready, we're going to create a workspace known as a tenant to deploy the application. We call this tenant CT scan and place it in the infrastructure we just created. Now, let's go about creating the hosts in the tenant against high-level specifications. These specifications include the subnet, VM size, and name. We can provide simple yes/no inputs for encryption and connectivity for log analytics, while under the covers, the bot will auto-generate the nuances like connectivity to Key Vault for the encryption key, provisioning, custom extension for log analytics, and so on. Given our architecture, we need to continue deploying the additional virtual machines. If you can recall, there are 2 web app virtual machines and 4 business tier virtual machines within these subnets. we are going through and creating the specifications for each of these. While the VMs are provisioning, let's go and look at the artifacts in Azure. We see a resource group has been created, and the required resources are being provisioned within that group. Now we see that all of the machines are in a starting state. Let's look in the log analytics workspace, showcasing that the virtual machines that we launched are connected and provisioned. Now, let's look at, apologies. Now, let's go about specifying a tag at the level of the tenant and infrastructure, thus eliminating the need to tag each and every individual resource which would not have scaled. Note that these tags can be modified at any point of time, and the bot will take care of propagating them to the individual resources. We're going to go ahead and take a look and see that these tags have been placed. Now, we can consider the amount of code that has been saved. As we export the template, you can see that we've saved another 1,500 lines of code across both files, 764 in this case. And as we hop through the parameter file, you'll also see the tags, along with the rest of the code. As a final step, we can now place the web virtual machines behind a load balancer. To do so, we're going to go ahead and set the allocation tag to web01 for both of these hosts. We go about creating a construct in DuploCloud called a service that represents, in this case, a unique application gateway, and we specify the ports and the health check, and we do again provide some declarative inputs to the bot, and it will provision the application gateway in Azure in the appropriate subnet and create the appropriate load balancer rules. DuploCloud provides you with a mechanism to move away from micro-operations where a user has to specify each and every input to a higher level of specification based on business needs, letting the bot take care of the infrastructure nuances as well as per the well-architected framework and security standards.